This video will go over the foundational knowledge needed to recognize and find vectors. So what are vectors? A vector describes a movement from one point to another, and a vector has both direction and magnitude. So here you can see the vector AB, and it's important to note the direction in which this vector is going in. And a vector is indicated by an arrowhead, and in this case the arrowhead being on top of A and B. And examples of vectors include displacement, velocity, and acceleration. So as I previously said, the direction in which the vector is going in is important because it will determine whether it's negative or positive. So see, we have the vector AB, and let's say AB is equal to C. If we were to find the vector BC, it would be the opposite of C, so it'd be negative, so it'd be minus C. So in order to find vectors, I like to use something called the triangle rule, which work with all vectors. And let's say I have this triangle OAB, and I want to find the vector OB. I'm going to start out by writing the first letter, so O, and then I'm going to leave a gap and write the last letter B. So you're starting from O and you're ending at B. And I'm going to put plus in between, and I need to fill in this gap with the triangle. So here the triangle's OAB, I'm going to fill it in with A, and that would find you the value of OB if given the values of OA and AB. So as I said before, it's important to know the direction in which you're going, because obviously you can have a positive and a negative value if you're going in opposite directions. So let's say OA is equal to A, and let's say BA is equal to 2B, and let's give OA the value of C. So if we were to say what OB is equal to, we would be saying that OB is equal to OA being C and AB being minus 2B because we're going in the other direction. So we would be doing OB is equal to C minus 2B. And you can say A is equal to C minus 2B because we've been given the value of OB. As you may have noticed, there are two different ways in which the vectors are represented, between points and arrowhead, and the actual value of the vector line drawn underneath. So that's what the triangle rule is, and now we'll be moving on to midpoints along a vector. So if I had the vector OG, and let's say OG is 2B minus A, and let's put the midpoint M between OG, so M being the midpoint. So that what that will mean is that OM will be equal to 2B minus A divided by 2, seeing as OM is halfway between OG. So as we were looking before, let's say I wanted to find MO. So first I'm just going to simplify OM. So that would give you B minus A over 2, 2 divided by 2. And therefore MO would be equal to minus B plus A over 2 as it's going in the other direction to OM, opposite direction. And I'm just going to rewrite that as A over 2 minus B. So another way in which vectors can be represented is via column vectors. So here we've got the column vector 2, 3, represented by the round brackets, and here the top number would show movement left to right. So if we would start from 0, so 0, 0, center, if we were on a graph, minus 2 would be moving 2 to the left, and positive 2 would be moving 2 to the right. Bottom number shows movement up and down, so positive 3 is up, negative 3 is down, so 3 up and 3 down. So if we were to say that the bottom left here is center 0, 0, we'd do it as so 2 to the right and then 3 up, and we would join the 2 points up and get the vector. And yeah, you may be asked to represent this on a graph. So here's another example, minus 2, 4. So we would go 2 to the left, then we would go 4 up, and we would, so from where we started to where we finished, we would join the points up. And it's very important we show the direction the vector is going in, which is represented by the arrow. You may also be told to add column vectors. So let's say we had the column vector A and B, A being minus 2, 3, and B being 5, minus 1. So this is simple addition, just simply minus 2 plus 5 for the top, and 3 plus minus 1, so you'd get 3 and 2. So let's look at another example, 2a minus b. So same concept, so we'd just be multiplying the minus 2, 3 column vector by 2, and subtracting the column vector 5 minus 1, so we'd get minus 4, 6, subtracted by 5 minus 1, and we would get minus 9 and 7. Here's a exam question to have a go at. Feel free to pause the video, and when you're ready, press play. So this question is showing you a triangle OAB, and in part A, it's asking you to find the vector AB in terms of A and B. So by using the triangle rule, we can see AO plus OB is equal to AB, as we started at A and we ended at B, and we used O to fill in the gap. And we have to be careful here because, as you can see, OA is 2A, not AO, so it's going to be minus 2A because it's in the opposite direction, and OB is 4B. So now part B is asking us to find ON, the vector ON, in terms of A and B, and in its simplest form. So as we can see, ON is equal to OB plus BN via the triangle rule. As we're starting at O and we're ending at N, so we'll fill it in with the B's, we'll put in the arrowheads. OB is given. We know that OB is equal to 4B. So now we need to find out what BN is equal to. As you can see, they said that N is the point on AB such that AN and to NB is equal to the ratio 3 to 1. So from here you can say that the whole AB vector is comprised of 4 parts, in which N is 3 and NB is one of those parts. And now we know this, we can say that NB is a quarter of AB, as it makes up one of the entire 4 parts of AB by the ratios. You have to be careful with the direction because NB is not the same as BN, and we want to find BN. So what we're going to do is we're going to find NB, and then from when we find NB, we're gonna take the negative of NB, as it has the same magnitude but it's in the opposite direction. So as you can see, I've taken the value of AB and I've multiplied it out by a quarter, and that leaves me with minus a half A plus B. And now I've found NB, I want to find BN because we're looking for ON, and ON is equal to OB plus BN. So I'm going to take the negative of NB in order to find BN, and then from there I'll be left with a half A minus B, and I can take the value for OB that I have, which is 4B, and the value for BN, which is a half A minus B, and I can add them together, and that will give me the overall answer for the value of ON. Simplifying down to 3B plus half A. So here's another example. Feel free to pause and have a go, and when you're ready, press play. So this question is showing us a quadrilateral, and in part A, it's asking us to express AB in terms of A and B. So we can see here's AB, and we're going to use the triangle rule. So we can either go from the left, AY plus YB, but we don't have the value for the vector AY, so we're going to go from the right. So it's going to be AO plus OB. We have to also be careful because here AO, the vector, is in the opposite direction as the vector OA, so it's going to be minus 3A plus 6B. So part B is asking us to prove that OX is 2/5 of the vector OY, and it says here that X is the point on AB such that AX to XB is equal to the ratio 1 to 2. So from here we can instantly say that AB is comprised of 3 parts, in which AX is a third of AB and XB is 2/3 of AB. So we've already found the vector AB, so we can instantly say that AX is equal to a third of minus 3A plus 6B, and XB is equal to 2/3 of minus 3A plus 6B. In order to answer this question, we have to find OX and allow ourselves to compare it with OY, prove the question. So by using the triangle rule here, we can see that OA plus AX is equal to OX, and that is going to be 3A plus AX, but we don't know what AX is, so we're going to have to find that. However, we just said that AX is equal to a third of AB, and that means AX is equal to a third of minus 3A plus 6B. Therefore, OX is equal to 3A plus a third of minus 3A plus 6B, and we can expand this to get 3A minus A plus 2B, which simplifies down to 2A plus 2B. So as you can see, the question, we have to compare OX with OY, so we just have to find OY, and OY is simple because as you can see, we're going to start at O, we're going to end at Y, so we're going to go from O to B, then from B to Y, and that's simply going to be 6B plus 5A minus B, and you're just going to get 5A plus 5B, and you can just make an easy comparison between OX and OY. See here, you can see OY is equal to 5A plus 5B, OX is equal to 2/5 of OY, because OX is equal to 2/5 of 5A plus 5B, which is equal to 2A plus 2B. In order to get the final mark, you have to show that comparison.